Today we learn about how to draw shear force and bending moment diagram when cantilever beam carrying a point load or concentrated load. So we can clear it with a cantilever beam 3 meter long carries concentrated or point load of 5 kN, 7 kN and 4 kN at distances 1 meter, 2 meter and 3 meter respectively from the fixed end site, and draw the shear force and bending moment diagram for the beam. So it is a cantilever beam. First load is 5 kN, that is acting 1 meter apart from the fixed end side, and the length of this beam is 3 meter, and this is 5 kN at a distance of 1 meter from fixed end. 7 kN, that is acting 2 meter apart from the fixed end, and this is 4 kN, that is acting at a distance of 3 meter from the fixed end, and we can say at the free end of the beam. Before drawing the shear force diagram, first we know the sign convention for shear force, and these are the points A, B, C, D. When left hand side moves upward and right hand side moves downward, so then we draw positive shear force. It is in clockwise direction. And when left hand side moves downward and right hand side moves upward, so then we take negative shear force, and it is in anti-clockwise direction. So now we have to calculate the shear force at particular points. So first one is the shear force at FT, the shear force at left of the, you can say at right of the D, shear force FD, that is at just right, equal to 0. And when we are talking about FD just left, so it includes the load 4 kN. So it becomes FD just left becomes 4 kN, and this 4 kN it remains constant between C and D point. So FC just right equal to 4 kN, and when we take the point FC just left, it includes the 7 kN also. So then it becomes 7 plus 4 equal to 11 kN, and this 11 kN remains constant between B and C, and FB just right equal to 11 kN, and FB just left, it includes the 5 kN also. So then it becomes 5 plus 7 plus 4 equal to 16 kN, and this load is remains constant up to point A, because there is no another load acting this portion between A and B. So at FA it is also equal to 16 kN. So now we draw the shear force diagram. All the values, these are a positive value, so the shear force diagram will be plotted above the baseline, and the length of the baseline is equal to the length of the beam, that is 3 meter. So here we have 4 points A, B, C, D. At point D, shear force varies from 0 to 4 kN, and this remains constant between C and D, and from C it varies from 4 to 11 kN, and this 11 kN remains constant between B and C, and from B it varies from 11 to 16 kN, and this 16 kN remains constant up to point A. So this is the positive shear force diagram. We plot the bending moment diagram. So bending moment sign convention, first we know, when left hand side and right hand side of the beam moves upward, then we take positive bending moment. When left hand side and right hand side of the beams moves downward, so then we take negative bending moment. So here we have 4 points A, B, C, D. So one by one we calculate the bending moment at these points. So we take the moments from free end and moves towards fixed end. So now the bending moment at point D. So as we know, moment this is the product of load into distance. So at when we start from D and bending moment at this point D, So there is no distance we cover, so if we take 4 into 0, then it becomes equal to 0. So bending moment is at free end, it is equal to 0. Now we calculate the bending moment at point C. So for calculating the bending moment at point C, we move from D to C, and the distance between D to C, that is the 1 meter. So the bending moment at point C, this is equal to 4 into 1, so that is 4 kilonewton meter. We take the negative sign because the load is acting, that is in downward direction, and we plot in bending moment diagram. We start from D point at 0 and we move towards 0 to, this is the 4 kilonewton. We draw these particular lines below the baseline, so it means these are the negative values. So now the bending moment at point B, and the distance between B and C is 1 meter, and distance between B to D, that is 2 meter. So for calculating the bending moment at point B, the load 4 kilonewton moves toward B and load 7 kilonewton also moves toward B, and 4 kilonewton load that cover the distance 2 meter. So that is the 4 into 2. This is in negative because it is downward, and load 7 kilonewton when it moves up to point B, it covers distance 1 meter. So that is also negative 7 into 1. So finally the load at B, that is negative 4 into 2 plus 7 into 1 equal to minus 15 kilonewton meter. So in on bending moment diagram, the inclined line moves up to minus 15 kilonewton meter, as we can draw here. This is the up to point 15 kilonewton meter, that is negative value. So now the bending moment at point A. So for calculating the bending moment at point A, all the point load acting at B, C and D, these moves towards point A. First 4 kilonewton, it moves up to A, so it covers the distance 3 meter. So 4 into 3, that is a negative 7 kilonewton, that covers the distance 2 meters, so that is 7 into 2, and 5 kilonewton cover the distance 1 meter, that is 5 into 1. So all these values, these are in negative because these are acting downward direction. So finally the bending moment at point A, it is negative 4 into 3 plus 7 into 2 plus 5 into 1, so it is equal to minus 31 kilonewton per meter. So on bending moment diagram, the line from 15 kilonewton meter, it moves up to 31 kilonewton meter. So all this diagram that is drawn below the baseline, so it showed it is negative, and it is the negative bending moment diagram. And one point we need to remember, that the bending moment diagram in case of cantilever, that is always drawn below the baseline. Subscribe to get more updates on mechanical topics. Anuniverse 22. You may like, share and comment, and give your suggestions if required. Thank you. Have a nice day.